ESA, the European Space Agency, believes the European market can support one commercial heavy launch vehicle, in addition to the Ariane 6, and two medium launch vehicles in addition to the Vega C launcher. First, let's define terms. According to ESA's definition, a medium launch vehicle can lift between 2 and 20 tons into low Earth orbit. This is similar to the capabilities of ESA's Vega vehicle. A heavy lift vehicle can lift between 20 tons to 50 tons into low Earth orbit. Both the Ariane 5 and Ariane 6 with maximum payloads around 21 tons fall into this category. This leads us to a question. Are there any European commercial space startups capable of delivering launch vehicles in either the medium or heavy lift categories? Before we attempt to answer that question, let's first look at an ESA study exploring the development of a new European heavy lift launcher. This could provide insights into future capabilities and market potential. Super heavy lift frequent flights to space for Europe. In 2023, the European Space Agency commissioned a study to develop a cost-effective, environmentally friendly heavy lift launcher for Europe. ESA's primary goals were to keep costs low while minimizing environmental impact. They chose Ariane Group, the creators of Ariane 6, and Rocket Factory Augsburg, a German space startup, to lead the study. A key feature of the launcher would be reusability, with at least the first stage reusable and ideally the second stage as well. To achieve this, the launcher would need more powerful engines, like the staged combustion engines developed by SpaceX and Stoke Space. RFA has already made efforts in this area, successfully testing their full-scale staged combustion engine Helix. For environmental reasons, the study recommends using biomethane and hydrogen as fuels. However, there's a trade-off here. Biomethane, when produced from low-carbon electricity, is costlier, and hydrogen, while offering high performance and resulting in water vapor when combusted, is a great deal more expensive and challenging to handle. Hydrogen's issues include its propensity to leak, cause metal embrittlement, and require storage at extremely low temperatures. In addition, large tanks are required due to its low density. Using hydrogen can potentially reduce launch cadence by complicating the logistics and operations and increasing the risks of launch delays. Just look at the delayed launch of the SLS vehicle to see the impact of using hydrogen, and the operator is NASA, which has decades of experience handling hydrogen. At one point, NASA had to send in their red team onto the pad of a fully loaded SLS vehicle to fix a valve leak. Pretty risky behaviour just to get the vehicle off the pad. Another problem, perhaps this is only for Europe, but the narrow roads and low bridges means that any rocket design that is 4 meters in diameter or more won't fit under a bridge when being transported. The current state of commercial launch providers in Europe. Most space startups are focusing on the small satellite launch market, launching from 300 kilos to 1500 kilos of payload to orbit. However, this falls short of the European Space Agency's classification for a medium launch vehicle, which begins at 2000 kilos. Some startups have more ambitious plans. For instance, PLD Space, a Spanish space startup, is currently building the Mura 5, which can lift 1000 kilos to orbit. However, they announced plans in 2024 for the Mura Next family of rockets that have dramatically increased payload capabilities. Mura Next can lift 13.5 metric tons to low Earth orbit in expendable mode. Mura Next Heavy, with 2 additional side boosters, this version can carry 36 tons to LEO, and Mura Next Super Heavy, the most powerful variant, capable of lifting 53 tons to LEO, and impressively, it can also deliver 16 tons to the Moon's surface in expendable mode, or 3.6 tons if reused. PLD Space appears to be the only European startup with concrete plans spanning medium, heavy and super heavy launch capabilities. Meanwhile, Rocket Factory Augsburg has potential to enter this segment, given their success with testing a high-thrust engine. However, this would hinge on market demand and the successful debut of their RFA-1 rocket. With somewhat less certainty, ISAR Aerospace stands out as another potential player. They are nearing their first launch attempt and are well funded with over 400 million euros from investors, ESA, and the German government. However, their capacity to scale up to medium or heavier launch vehicles remains to be seen. In conclusion, this year, that's 2025 at the time of recording, several European space startups should be attempting launches. RFA-1 is anticipated to take off from Saxavord. ISAR Aerospace plans to launch their Spectrum vehicle from the Andøya spaceport in Norway. PLD Space is set to send their Mura 5 rocket into orbit from Kourou, French Guiana, likely towards the end of 2025. Orbex launching their Orbex Prime vehicle from Saxavord, and Latitude Space should be launching their Zephyr launch vehicle in late 2025, also from Saxavord. We can also expect suborbital launches from High Impulse launching their SR-75 vehicle, and Skyrover launching their Skylark L vehicle. These launches will take off from the Saxavord spaceport in Scotland. We'll keep you updated on all these launches and any news regarding these companies' plans for larger launch vehicles. That's all for now. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.